Hey guys, just wanted to talk you through the last slide of chapter 3, and that's talking about theoretical yields and actual yields. So the definitions for these are pretty straightforward, but it's the calculations that can be slightly tricky. So I just want to talk through those in just a couple minutes to make sure everybody has this idea straight. So theoretical yield, the term yield that we're using here, that term just means like what can be made. So when something is yielded, it is made or produced. So automatically when they talk about a theoretical yield or an actual yield, you're always talking about products. You are never talking about reactants. Now, this term theoretical, we threw around when we were talking through limiting reactants and combustion analysis. So theoretical yield is what you possibly could make from any given quantity. It's not necessarily what you will make. So a couple slides ago, we had this question where they gave us, let me actually go back, see if I can find it. Okay, this question, they gave us amounts of zinc and amounts of silver nitrate. So we had 2 grams of zinc and 2.5 grams of silver nitrate. So remember on this problem, you are given 2 grams of zinc in your beaker. That's your starting amount, but you're not necessarily going to use all of that zinc. If the silver nitrate runs out first, then you're going to have leftover zinc. So that 2 grams of zinc can be calculated into the mass of silver, and that's a theoretical yield. In theory, we could make that much silver if we use all of our zinc. But what we found was where zinc was our excess reagent, so we're not actually going to make this much zinc because we run out of silver nitrate first. So when you are calculating the yield that can be produced, you just have to be really careful that you start with the limiting reactant. You have to start with limiting reactant before you can calculate how much your experiment is going to yield. So if we start from silver nitrate and we calculate 2 silver, that amount is going to be our theoretical yield. Okay, so here's the catch. We're still using this term theoretical. So if I use all of my silver nitrate and I calculate 2 silver, that amount is still going to be my theoretical yield for a couple different reasons. Now let me go back to the other slide and I'll talk about why. Okay, so when, again, just one more time, it's the maximum amount of product that can be formed. So when you're calculating theoretical yield, you have to start from the limiting reactant. And if you haven't noticed, reactant and reagent are used interchangeably. 2 words to mean the same thing. Okay, so you start from your limiting reactant, you calculate to a theoretical yield, and what that number means, it's the max amount of product that you possibly can produce. If all of your limiting reactant gets used up, you can produce this amount. Are you going to produce that amount? Probably not, because for a couple different reasons. First of all, reason number 1, virtually no reaction actually goes to completion. If we had a reaction that went to completion, that reaction would be 100% efficient, which would be amazing because it never happens. So for example, efficiency of like a solar cell captures about 1 to 2% of all the sun's energy that enters through our atmosphere and hits that solar cell. Not very efficient. If you're talking about like a combustion engine, so an engine where you pump something in and you burn it and it makes the engine go, like the engine that's in your car or probably your lawnmower if you use a gas lawnmower. Those kind of things are combustion engines. So efficiency of a combustion engine is probably somewhere around 20%. Again, not very efficient. And chemical reactions are no different. When you run a reaction to completion, you're going to be super happy if you get about 70% efficiency, which means the reaction goes forward and then the reaction just naturally stops before all the product is used. And we're going to talk about this concept when we go into the chapter called equilibrium. What happens is our reaction actually hits an equilibrium. And actually our like whole second half of our class is all about the equilibrium that chemical reactions hit. So that's one of the reasons why a theoretical yield, usually you can't actually produce that much. Another reason is because of side reactions. So we usually are trying to target a very specific reaction. For example, if you are in the business of producing ammonia and you're going to sell the ammonia that you produce, you want your nitrogen and your hydrogen to react and produce ammonia. That would be ideal. But sometimes the nitrogen and hydrogen react to form something that's not ammonia, or sometimes the oxygen in the air gets combined up there and you're gonna form a side reaction that's not ammonia. So side reactions also happen and they interrupt the theoretical yield. Okay, so there's a couple other ideas, but you get a couple other reasons, but you get the idea. A theoretical yield is the maximum calculated amount, and you must be calculating from the limiting reactant. It's probably not actually going to be produced in your reaction, but that's okay. Oh yeah, here we go. Seldom produced because of side reactions and other complications. Okay, so that's theoretical yield. Actual yield. So an actual yield is what you do actually make and collect after the side reactions, after you hit equilibrium. So let's say in our theoretical yield of silver, I don't remember what it is off the top of my head, but let's say it's like 4.2 grams. That's going to be our theoretical yield of silver. Our actual yield is always, always, always going to be smaller than that. So your reaction doesn't go to completion, your reaction hits all these side reactions, and you are going to produce in your beaker, let's say 1.7 grams of silver. That's your actual amount. So the actual yield must be experimentally determined. The theoretical yield is calculated. The actual yield is determined by an experiment. So you can't actually get an actual yield unless you have done an experiment and have the data from that experiment. And then if you put the two together, what you actually get from your experiment over what you have calculated you should have gotten, what you get is something called percent yield. So actual divided by theoretical times 100 equals your percent yield. Okay, so lots of terms. They all sound very similar to each other. What I would do if I was trying to learn something like this is I might draw like the procedure of an experiment, and then I would label in that procedure, okay, here's where my theoretical yield is, comes from a calculation. I have to start with a limiting reactant. Here's where my actual yield is. That's actually what I collect inside my beaker. And when I divide the two, I get a percent yield. So drawing that conceptually out and then marking where these three things can be drawn from, that's my method that's the Martin's method for memorizing stuff. So feel free to steal that. All right, see you in class.